Hello everyone, in this video we're going to look at problem number 8 on section 3.2, and we're trying to see how many inches will this weight in this figure rise if this pulley is rotated through an angle of 78 degrees and 40 minutes, and that's around that much, slightly less than 90 degrees. So basically, when that rotation occurs, this kind of an arc will be traversed on the pulley. And of course, as that movement occurs, this weight will go up by exactly the same length. So if we call this arc length here S, this distance that the weight will be lifted will be the same distance S. And this angle here is 78 degrees and 40 minutes. So we're basically going to be using the arc length formula. This is nothing more than an arc length problem. So we know that S is given by r theta. The only thing is that this theta needs to be in radians. And of course, the problem is giving it to us in degrees. So the first thing we'll do is we'll go ahead and convert this measure that's given here, 78 degrees and 40 minutes, into radians. So if we just start with 78 degrees and 40 minutes, first we'll just turn it into all degrees. So that's 78 degrees plus 40/60th of a degree, because you know there are 60 minutes in 1 degree. And if we simplify this, that leaves us 2/3. So this is basically 78 and 2/3 degrees. Now, in the interest of accuracy, we're not gonna get a decimal estimate for that. We're going to keep it as is. So if we go to something like Desmos and turn that into an improper fraction, we're going to multiply 78 by 3 and then add 2 to get 236. So we get 236 over 3 degrees. So now we're going to take that 236 over 3 degrees, and we're going to multiply it by the unit factor required to turn that into radians. And if you recall, that's going to be pi over 180 degrees. So basically, again, I don't want to multiply the pi in. I'm going to just multiply out these numbers. So the 3 and 180. So I end up with 236 over 540. And we have a pi that's still going to be there on the top. So that now we know is in radians. So we can safely use it in the S equals r theta formula. And we're going to end up with, let's go back to our problem. The radius is 9.26 inches. So we get 9.26 inches times the angle, which is now 236 pi over 540. So now we're going to do all the calculation in one shot for best accuracy. And we notice that if we plug it back into Desmos, we're going to get, so we're going to multiply 236 by 9.26 0.26 pi, and then the order of multiplication doesn't matter, so we're going to divide that by 540. So we get 12.71, etc. So we go back to the problem and see that they wanted it rounded to the nearest tenth. So to the nearest tenth, as you can see, just as we had in Desmos, it's around 12.7 inches. Okay, so that's where our first answer comes from. Now we want to see in part B, through what angle to the nearest minute must the pulley be rotated to raise the weight 3 inches? So notice we're still going to be using the arc length formula. The only difference is this time we know the arc length and we're trying to find the angle corresponding to a movement equal to that arc length, which is 3 inches. So we're going to substitute 3 for S. We know the radius, it's 9.26, and we're trying to calculate theta. So we get theta equals 3 over 9.26. That, of course, is in radians. And if you notice, they want the answer to the nearest minute. So that means not only are we going to convert it to degrees, but in fact, we're going to convert it to degrees and minutes. So to do that, as you know, we have to do the opposite of what we did over here. And instead of multiplying by pi over 180, this time we're going to multiply this by 180 over pi, because even though we don't write radians next to this right here, we know that it's there. In fact, if we want to, we can even put it there. We can put radians here and then put radians here to there. It doesn't matter because they're going to cancel out. So now we're just going to go back to our calculator and we're going to calculate 3 times 180. That's going to be our numerator, and downstairs we're going to have 9.26 pi. So we get approximately 18.56 degrees. And of course, if you recall, they want the answer in degrees and minutes because they want it to the nearest minute. So now what we're going to do is we're going to say that's 18 degrees and then 56 hundredths, or 0.56 times 60 minutes, because this time we're going from a larger unit to a smaller unit, and as you know, we have to multiply now by the conversion factor. And if we do that, we get 18 degrees. So if we go back to our calculator and multiply 0.5, oh, let me erase that, 0.56 by 60, we get 33.6. So to the nearest whole minute, it'll be 18 degrees, 34 minutes. And that's where our second answer comes from. So that's how we take care of a problem like that. So be safe until the next video.